Aerospace Engineering, Monday, January 11th, 2021. I'm making up a practice truss problem for analysis. This truss is a right triangle. It's against a wall. The pivot point is up here at the top of the truss structure. If each grid on this graph paper represents a distance of 1 meter, then down here at a distance of 8 meters is the roller. A distance out of 4 meters is this vertex here where a load of 100 newtons is being applied. And the question becomes, great, what are the reaction forces? And later on, what is the tension and compression for each of the three members of the truss? All right, go ahead and do this faster than I can. Right? You guys should just be zipping to the answer already. For starters, I could pick the pivot point to be my axis of rotation and calculate what the moment is for this load about that pivot point. My favorite is to slide the forces along their line of action. So if this pen cap tip represents the force, I can back it up along its line until it becomes perpendicular to the axis of rotation, and then count over. So 1, 2, 3, 4 meters is the value of R. 100 newtons is the value of the force, and the angle from R to F is negative 90 degrees. So right away, I can tell you the moment is negative 400 Newton meters. Trying to make this thing twist clockwise. The only way to cancel that is by an outward force through this roller, a counterclockwise moment. So even though there's no horizontal load being applied here, this roller has to push horizontally to the right, and its moment has to cancel the moment caused by this load. So the value of R is 8 meters, and therefore negative 400 Newton meters. Now make that positive 400 Newton meters because we want it to, cancel. Divided by 8 means there is a reaction force of 50 newtons pushing outward from the wall. Imagine if this wall weren't here, this structure would rotate underneath the vertical from this pivot point. So yes, the wall is necessary to counter this load. It's pushing 50 newtons to the right because 8 times 50 is 400. Positive 400 of counterclockwise torque will cancel the negative 400 Newton meters of the clockwise moment caused by the load. Sometimes they call it torque. Project Lead the Way always calls it moment. Okay, well, there's more. If I'm pushing to the right with 50 newtons, then for the sum of all the forces in the horizontal direction to add up to 0, the pivot point must be pulling to the left with, go ahead, say it, 50 newtons. And if the load is pulling down with 100 newtons, then the reaction force up here at the top must be pulling up with 100 newtons. I'm done with the reaction forces. I have a load of 100 newtons out here, a reaction force of 50 newtons down here. I guess I can call this top one A because I've always been putting the pivot at A and the roller at B. This point out here is C. And now to calculate the tensions and compressions for each one of these members. Interesting, you say. Well, here's one thing about this particular geometry. This vertical member is neither under tension nor is it under compression. Isn't that interesting? It is neutral. So I use T for compression, I'm sorry, I use T for tension, C for compression, and the software I use uses N for neutral. So it's actually 0 newtons, oh no, for member AB. Meanwhile, let's take a look at member BC. If B is pushing against this member by 50 newtons, then C is pushing towards B with 50 newtons. So B and C are pushing towards each other, and member BC is under compression. It's being squeezed by BC, and so it's pushing outward. If you like, I put these very confusing arrows on it saying, look, member BC is pushing against B by 50 newtons. It's pushing against C by 50 newtons. So 50 newtons is the amount of compression of member BC. What's going on between A and C? Well, the load is pulling C down with 100 newtons. So A must be pulling C up with 100 newtons. So this is pulling A and C together. I guess I could show the arrows going this way. They're pulling inward from outside. The vertical component is 100 newtons. The horizontal component is 50 newtons to the left, because BC is pushing C to the right by 50 newtons. AC must be pulling C to the left by 50 newtons. So I can tell you that the vertical component of AC is 100 newtons. The horizontal component of AC is 50 newtons. And fortunately, we have calculators and we know Pythagorean's theorem. So we go 50 squared plus 100 squared, beep, 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 and it says this is 12 newtons. It says 111.8033989. So we'll call that 112 newtons of tension. The downward pull of AC at point A is 100 newtons, canceling the 100 newtons reaction force going up to point A. The pull of AC on A to the right by 50 newtons cancels the reaction force of the wall pulling point A to the left by 50 newtons. So we're done already. I just thought I'd like to point out to you once again that member AB is technically neutral, but if it were not there, then in real world, member BC would fall down because there's nothing keeping it from falling down. We treat it as if it's massless for our calculations, but it has a little bit of mass, and therefore gravity is going to be acting on it. Okay, I'm going to pause my recording. All right, resuming recording for this session. The fall content for Project Lead the Way honors Unit 1, Introduction to Aerospace, leads off with the evolution of flight. Within this, there are a lot of historical events that we certainly want you to know, beginning with December 17th, 1903, the Wright brothers' first flight from Kitty Hawk. What makes this flight different from its predecessors by other flyers is that this was the first time that flight was controlled by the people on board, and they used an engine and a propeller to control their flight. No one had put an engine on board before. Ideally, you'd know a little bit more about what the Wright brothers had to go through. So they were two brothers they had a bicycle shop in Ohio, and they dreamed of flying. They did it intelligently, so they wrote to the U.S. Government and asked, "Where can we study your weather maps? We want to find a location in the United States where there's good, steady winds that are reliable for our glider experiments." And so they studied that, and that's how they selected Kitty Hawk, North Carolina. They built gliders and flew them and studied them. They figured out they wanted to put an engine on board their aircraft. The engines available at the time, 1903, 1902, 1901, were primitive, and they needed a light engine, so that was kind of a challenge. Another challenge was no one had ever made an airplane propeller before. So they wrote to shipbuilders and asked them for guidance on how do you design propellers for ships going through the water. And the response they got was, well, we just do trial and error. So it was left to the Wright brothers to figure out a design for their propellers as well. They progressed step by step along with other researchers. There's a place out here in California that also has great steady winds. It's down in San Diego. It's Torrey Pines. I've gone paragliding there. It's my longest flight. And you can go down and watch people who are just flying back and forth on the wind, smashing into the 600-foot high cliffs off the Pacific Ocean, providing steady, smooth, rising air to go gliding in. Anyways, enough about the Wright brothers. You should know a lot about them. The fast advancements, the U.S. Army buying its first contract, making its first contract with the Wright brothers to develop an aircraft. Militaries around the world were keenly interested in this new flying machine because it meant, okay, you can go over your enemy's territory. You could cross a river without having to build a bridge by flying across the river. Things that were new ideas, right? So, uh, gyroscopes were invented, autopilots were invented, a compass put on board. Through trial and error, through death and dismemberment, people realized, oh, we need to put in more and more instrumentation, more situational flight awareness, more human factors. And it's still going on today. When the, oh gosh, when people die, there was an airplane crash this past weekend. People have died. It was a Boeing 737. There's the there are people who are going to study what went wrong. And one of the first pieces of data that they hope to get and have already recovered in this case is called the black box, which is not black because that makes it harder to find. So it's painted a nice bright color and it's designed to withstand crash and impact forces. And within it, there used to be tape recorders, and now it's more digital. So memory chips that are keeping track of the flight data as it's being generated by cockpit voice recorders is one part of it. A recording of all the sensors and what they're reporting to the computers that are on board the aircraft. So it's still going on. You should recognize that military conquest and the war have traditionally been big pushers of new technology. So when you look at World War I, you should recognize, oh, biplanes, Sopwith candles, machine guns on board, the very first use of an airplane for delivering a bomb to the ground. The Wright brothers, they had imagined that once the airplane was invented, war would no longer be possible because it wouldn't be possible to defend against a bomb being dropped out of the air. Well, as you now know, over 100 years later, we are still having wars. They are even much more deadly than they were in World War One, and aircraft are a uh, major component to war fighting capabilities. Aerospace is. missiles and planes and drones and smart bombs, all of that is aerospace technology. There is some good that came out of this as well. So stuff like airmail, uh, which was a program by the U.S. government to help develop air travel. You should certainly know about individuals involved with certain accomplishments. You should know about Charles Lindbergh. You should know about Amelia Earhart. You should know about, oh gosh, certainly Chuck Yeager. I would, and there's more. I mean, you guys were tasked with coming up with some topics and presenting it in class. World War II, and the Wright brothers, one of them died kind of early-ish, and he was sort of distraught into his grave with competitors um, trying to steal his inventions all the time, and he had to fight, and it just drained him to death. But the other Wright brother lived through World War II, I believe. I believe he lived till at least 1947, and so got to see, you know, the evolution of aircraft to what must have been unimaginable to him to see. Okay, even the jet aircraft was on the horizon, figuratively, when he passed away. Oh boy! So militarily, it's still going on. You could read about uh, the aircraft that's used for bombing, for surveillance, for air superiority, for all that good stuff. Uh, but there's more too. So rockets came along. It'd be great if you knew about Robert Goddard and could explain about him in depth. You should know back to aircraft what NACA was, the predecessor to NASA. You should certainly know information about the space race. Welcome back, Sylvina. You should know details about the space race, certainly beginning with Sputnik. And actually, I shouldn't even say beginning with Sputnik. You really should begin with Robert Goddard in the 1920s, and then how Werner von Braun took Robert Goddard's ideas and transformed them into the V1 and V2 rockets, Victory 1, Victory 2 rockets used by Germany during World War II to attack England. At the end of the war, von Braun and some of his top scientists were snatched by the US, and the other half of the scientists were snatched by the USSR. So we had two Nazi rocket scientist teams competing against each other during the Cold War. The Soviets had Korolev, and he put together the first artificial satellite launch, Sputnik, on October 4th, 1957. The United States tried to catch up, and we publicly showed our launch attempts, and they crashed and burned, literally exploded in a fiery ball on the launch pad. You could, you should study some of the history of NASA. Uh, Gosh, the first U.S. satellite to be successful was Explorer 1 uh, in early 1958. It'd be great if you knew details about the Mercury 7, if you knew some details about uh, Mir, of course, and the Soyuz space stations, the Soviet programs. The Soviets and the U.S. competed for space first. So, first two-person uh, spaceship to go into orbit. First three-person crew to go into orbit. Soviets. First woman in space. Soviets. First space rendezvous. Well, we credit that one to the Soviets. Turns out they had no capability of doing the rendezvous, but no one knew that at the time except maybe the Soviets. First spacewalk, first person to orbit the Earth. A lot of those are Soviet accomplishments. Uh, so, know about the Apollo program. So President Kennedy said, okay, give me a space first that we can do where we can actually have a chance of winning. And, the question was build a space plane? No. Build a space station? No. The Soviets would beat us on stuff like that. How about first person to walk on the moon? Okay. So that became the Apollo program. And to prepare for it, the purely engineering program was Gemini, trying to figure out how long can people live in space and still function? How do you rendezvous? How do you navigate? How do you, do recovery? How do you do spacewalks? That was a pure engineering program, two-man crews. Apollo was designed as a three-person crew because back then they didn't realize they could use computers to monitor things while the astronauts slept. So they imagined that you need three people, each person doing an 8-hour shift, and they take turns, and that's why you need three people. Totally unnecessary today, right? Huh. And the Soviets almost did beat us to the moon. The geometry was their launch site was favored 12 days before our launch site was favored in terms of lining up with where the moon was as a target in space. They had their rocket fueled, and there was an explosion of the rocket on the launch pad, and that is what prevented them from being the first to orbit the moon with a person on board. The rocket did not have a crew on board when it exploded. Oh man, we have a 3-minute break, and I haven't even gotten out of the first section of the first unit. I don't have much to say about these.